Yeah, welcome to a massive open online course on chemical process intensification. Uh, in this lecture, we will learn about some principal features of this chemical process intensification. So, in the previous lecture, we have discussed about the brief history of this process intensification, as well as some features. Here also we will discuss something more about that features and also some examples according to the different type of features. Generally, four principal features is generally followed to achieve a completely intensified process as per Garvin and Stankiewicz 2009. They actually told that these four basic principles as shown in here in the slide, like here uh, in this case first one is the effectiveness of the intra and intermolecular events. Actually, the process intensification that starts from the molecular level, and based on that molecular interaction, the effectiveness of that intra and intermolecular events, and based on that principle actually the process can be intensified. How molecule will be actually interacting to each other, and based on which how that molecule will actually enhance the process, like any chemical reactions or any other physical phenomena of that particular materials, that depends on that intermolecular even intramolecular phenomena. And also you will see as a feature of that process intensification, it will provide all molecules the same process experience. In that case, you will see that molecules you will see have whether that molecules will be actually giving the same experience of traveling those that free path, like Brownian motion there, how molecules will be moving. Even is there any convective processes or heat transfer or mass transfer process in convective mode, there how molecules will be actually traveling and how those molecules will be interacting to each other. So, based on which the process can be intensified. And also many factors that affect on that particular intermolecular phenomena of any chemical process. So, in that case some that effect should be maximize to actually giving that particular process yield. So, they are maximizes synergetic effects from the partial process, which will be actually considered before going to that particular intensification of the process. And also that there are several driving forces are acting in a process, like mass transfer there will be driving force is concentration. So, you have to actually optimize that driving force for your process, and also based on that what should be that some coefficients of that phenomena of what is that processes, like that mass transfer, in that case suppose absorption reaction, that absorption of any molecules that depends on that concentration gradients in the phases. So, if we considered how much actually molecules will be transferred from one phase to another phase for that particular absorption operation, in that case that rate of absorption depends on the concentration gradient, and the proportionality constant, it is called that the transfer coefficient. So, this transfer coefficient depends on different operating variables of the processes, like if you are doing that absorption of that some carbon dioxide gas or gas phase absorption in a liquid medium. in that case overall mass transfer coefficient is considered as a proportionality constant. Now, that constant depends on that different geometric variables of the unit, even physical properties of the system, and also thermodynamic properties. Of course, there is a dynamic variables that is very important. So, in that case you will see that this mass transfer coefficient depends on that dynamic variables like flow rate of the fluid and physical properties, what are the fluids that is being taking part actually they are in reactions or absorption process, that physical properties of the system that will affect that mass transfer coefficient. And also the geometric variable size of the reactor, diameter of the column, even length of the column are the important factors for actually changing that mass transfer coefficient. And also other variables like temperature and pressure, those are called thermodynamic variables. These thermodynamic variables also main effect for the physical even reactive separation of the processes. So, whenever you are going to actually maximize or optimize the yield of the process, there you have to actually consider all those variables and also driving force, and these generally affect the scaling of the processes. Whenever you are going to scale the process from the laboratory scale to the industrial scale, that you have to consider all those mass transfer coefficient, and that mass transfer, how those mass transfer coefficients will be depending on the different operating variables. And also important thing is that whenever that dynamically changing conditions to attain kinetic regimes with higher conversion and selectivity, in that case this molecular effects is important. And also you will see that some performance of the processes that depends on flow regimes, whether it is plug flow or turbulent flow, laminar flow or slug flow, different types of flows, flow patterns are there in the multi-phase systems, because every reactions or any physical operation that actually involving more than one phases. So, it is called multi-phase flow. So, fluid, how it will be actually flowing, whether it is in plug flow phenomena or uniform actually heating gradients throughout the columns or not, that will actually affect that molecular interactions, and also that other performance or yields of the processes. And whenever you are going to maximize the synergetic effects from partial processes, that you have to actually consider the equilibrium of the reaction. So, how this equilibrium of the reactions is affecting by the variables, as well as even if you are just removing the products, that also will affect that the equilibrium condition of the reactions. And of course, that to optimize those processes, that you have to operate the processes based on that suitable operating conditions. And also if it is the interfacial phenomena reactions, then you have to increase the transfer surface area through the specially designed conduit or reactor there. There are several different types of reactions are there, and different actually designs can be done based on that increment of the surface area. Like if there is a gas liquid reactions, you can supply the gas through the liquid medium as a dispersed phase of our bubbles. So, there you can increase the surface area of the bubbles or increase the interfacial area through which the mass transfer will happen. So, these are the basic four principal features that is given by Garvin and what is that Sanquist in 2009. So, we can have these features, and based on these features sometimes this intensification is being done. Now, other features like this here, that one of the important principal feature of process intensification is that increase the productivity and selectivity through the intelligent operations. What is that intelligent operations? In that case, you will see sometimes some materials to be developed to actually enhance the productivity of the process, and also sometimes integrate the process in a suitable way, so that you can increase the selectivity and the productivity of the processes. Example like that nano or micro tailoring of the catalyst materials, that you have to develop in such a way that it will affect the productivity and the selectivity of an intelligent operation. So, based on these material characteristics, you can intensify the process there. Even sometimes it is called that multi-scale approach based process intensification. In that case, the process will be controlled by multi-scale approach for the process intensification. And for the process intensification, other important feature is that the design of the novel equipment based on the scientific principles. Sometimes if you procure some or you can design some equipment in such a way that it will give you the best that productivity of the processes, like nowadays micro reactors are coming. So, micro reactors, micro channel based reactors, where the gas liquid reactions will be doing through that micro channel, even extraction processes, liquid extraction through the micro channel based reactor. In that case, the reactors are being designed in such a way that will be a very small reactor, even to get the plug flow phenomena, and also to get the more interfacial area. This type of reactors are being developed. Even there are several other different types of reactors are being developed based on different that scientific principles, like that microwave reactor, even you will see that extractive distillation, even that there will be certain principles of electric field, electromagnetic field, how it will be actually used to actually enhance the reaction performance, even that separation processes. And also there are some other processes like centrifugal action, even some other process like sonochemistry, how to produce that micron size bubble or micro bubble it is called, and to increase the interfacial area of the reaction processes for that gas liquid reactions. So, in that way sometimes the reactors are being designed, novel reactors are being designed based on these scientific principles. So, this is also one of the important features of the process intensification. Even another features like new production methods, you have to think about that how we can actually produce different types of products, and also different methods to produce those products. So, you have to intensify the methods here, like that you have to that you cannot use the conventional process to produce that just separation processes. You have to intensify the process by developing new methods there. So, that is also one of the important features. These four basic principles also are given by Segovia, Hernandez and Bonilla Petriciolet in 2016. So, these are the some principal basic features that is given by them. Another important principle of this process intensification, it is called triplet feature, that is given by this Gabriel Segovia, Hernandez and Bonilla Petriciolet in 2016. They told that the basic principles of the process intensification should be as a triplet features, like molecular, first it will be one is molecular process, then from the molecular process it will go to the product side, and then after that process engineering. What is that actually? The molecular processes means here reactions to be done in the molecular level. After that after reactions some products will come, and whenever products will be actually obtained, that you have to separate those products and byproducts to give the certain degree of purity, and for that process engineering is very important in that aspect. So, these are the triplet features of this process intensification. Now, in this case by this triplet features you have to approach to the manufacturer and manufacturer end use of that is properties like that final product. To get it, first you have to do the reaction, then product, then separation processes of that product mixture. So, to get that product mixtures, you have to intensify the process unit, you have to intensify the methods, you have to intensify the that policy, so that you can get the final end use of the products that is being developed in your particular process intensification process. And also important thing is that the design and engineering using the triplet is also concerned about this triplet feature, that in that case implementation of that multi-scale application of computational chemical engineering modeling and the simulation to real life situation from the molecular scale to the production scale is required. So, very important that after producing that product, of course, you have to develop some that process principle or that simulate that process by which you can say that okay, based on this that operating conditions you can get this type of product. So, you need to have some simulation process based on those that experimental observation for this process intensification way. And in that case based on that simulation you can also that scale up those processes for the commercialization sector, and you can get that more precise way to interpret those processes after development of this process method for this process intensification. Now, according to Pons Ortega et al. 2012, they have given or they have suggested also some features of process intensification, like that they told that that to intensify the process you have to reduce the size of the equipment, and also you have to reduce the equipment hold up or inventory. That is why you will see that whenever there is a big process like there are several equipments are being used for a particular process. So, for intensification you have to reduce those equipment numbers or equipment size also. So, by reducing the number of the equipment and also size of the equipments, that can be possible to intensify the process. Also, in a particular that reactor there are several that inventory will be there, that is a huge amount of inventory will be there. So, you have one of the important features of the process intensification to reduce the hold up or inventory of the process, because that for that higher inventory or higher hold up will give you the a big size of the equipment. So, in that case if you reduce the hold up or inventory based on which that process intensification to be done, then of course, you have to reduce the equipment number and equipment size. And also the process intensification can be done by increasing the that throughput of the processes. Sometimes in the turbulent motion or turbulent flow based on which you will see there will be a intensification of the process, because they are at high throughput you can get more interaction of the molecules of the process as well as more mixing inside the bed. So, they are high throughput is also one important factor to increase the intensity of the mixing of the process, and based on which you can get more output of the process. Like in this case that heat transfer operation is also one of the important process, and based on this intensity of the mixing, as well as some other multi-phase flow systems, their mixing is important. So, you have to increase the throughput of the process to get the intensified that way to produce different products. And also efficiency of the process equipment you have to increase to get the process intensification for the particular process. So, in that case how to increase the equipment. So, you have to design the equipment in such a way that sometimes it may consume less energy. In that case the design should be based on that physical principles of the flow and also the properties of the flow. They are some liquids you will see will have some higher the frictions, because high viscous liquids to be actually sometimes to be used for the process. So, in that case you have to reduce the friction and based on that frictional resistance you have to design that equipment to get the better efficiency. And also if you use some materials, some raw materials, if you use through a particular equipment, that may corrode the equipments and it may not give the that sustainable way of output there, and the process will not be lasting long for that particular operation. So, you have to design those equipments in such a way that you have to consider the raw material properties, whether it is high viscous or not, or some other characteristics of the materials you have to consider, and based on which how to increase the efficiency of the equipments that is required for the process intensification. Other principles like that according to Orzuela et al., they have given in 2016, they told that process fundamentals is one of the important factor to intensify the process. If you do not know the fundamentals of the process, then you will not be able to design that particular process equipment, and based on which you will not be able to intensify the process. Even some constants also, several variables are actually involving for the particular process. So, you have to reduce that variables to get the intensified way of the process. Sometimes if you reduce the variables, you have to operate that process, or you have to consider the intensification of the process. You have to develop the new methods for that process, so that you can use less number of variables for that particular operation. So, you will get the less constraints for that particular process. Also, process design methodologies, you have to design that methods in such a way that it should be sustainable and also eco-friendly and economic there. And you have to use some optimization process to identify those variables whose that will be actually more intensive to give the output of the process. So, you have to optimize those process variables that sometimes you have to segregate, you have to remove some constraints to get the optimum value of that process, and for that you have to sometimes develop, or you have to integrate those other methods. You have to make a algorithm in such a way that you can get the best way of solution for that particular process optimization, because in the intensification process there is a complex method. You are considering different methods of intensification. So, there are variables will not be involving in a single variables, maybe that different variables will be involving, but that should be intensified where that should be more complex. So, in that case you have to use suitable algorithm to actually optimize the process. And also the controlling strategies also to be known, how those complex method can be actually that control for that particular intensified process. So, these are the also important features to design a particular process for your intensified way to get the output. So, this is these are common actually principal features for all process intensification. Another important features given by Lewis et al. 2010, and they told that the principal features of the process intensification should be that an other way, like sometimes you have to integrate the process. operation, like that two process should be in a particular unit, like reactive distillation, reaction as well as distillation, that is reaction and separation both will be in a single unit. So, you have to integrate the operations, that means here reaction as well as separation both will be simultaneously in a particular system. So, that is called integration of the operation. Here integration of functions also, there are several functions will be there are several variables will be there. So, both the variables or functions should be actually integrated in the process. And integration of the phenomena also, you will see there are several phenomena of the physical process, physical that theory will be acting on particular process. So, you have to integrate those principles or phenomena of the that system for that particular process intensification. And also that whenever you are going to have some targeted product by process intensification based on this integration of the operation, you will see several different phenomena will be acting simultaneously. So, you have to enhance that operation, you have to enhance the that mode of the operation in such way that phenomena based separation can be obtained there. So, this is also important that whatever target will be there after separation, what type of products you want to do, based on that you have to select some that phenomenistic materials, or some that some materials which will be more suitable in that particular process. You cannot use arbitrary materials to give that particular output. So, you have to wisely actually select those materials when you are going to have this that your targeted product. So, you have to consider those materials wisely for that process intensification. So, these are the features that is given by Lutz et al. 2010. These are also very important features that you have to keep in mind for the particular process intensification. Some other typical examples of the principal features of the process intensification, like we can divide in different way, like different or several principal features. Let us see that principle 1, integration of unit operation. In that case, suppose there is a reactor and membrane unit. So, you can develop the membrane reactor, so that the reaction and separation both will be happened in that membrane reactor. Like reactor and absorber unit, some reactive absorption will be there. Suppose there is a reaction, after that product will come, and that product, from those products you have to separate that byproduct and main product there, and some other contaminants that will be separated. So, some adsorber to be used, some adsorber like solid materials in a packed adsorber, or some other intensified adsorber to be used, so that the contaminant to be adsorbed on the materials and separated from the main product. So, in that way, that combination of this reactor and the adsorber unit, that is also one type of process intensification. And also extractive reactor, reaction as well as extraction both will happen simultaneously. So, that is why the process intensification should be integrated way for that reactor and extraction. So, that is it is called the reactive extractor unit. So, separation, like example here, separation of carboxylic acids from the wastewater via reactive extraction. So, this is also one of the important method by which you can do the process intensification in a simultaneous way for this reaction and extraction process. So, example here, as well as the direct conversion of methane in with integrated air separation process there, and some other examples like that hydro that tactic based adsorption reactor for the separation for enhanced water gas shift reaction, there reaction as well as that adsorption both will be happened in a particular operation. So, integrated operation. So, that is why we can say that one of the important feature of the process intensification is called integration of unit operation. Now, integration of functions, what is that? In this case, conversion and separation, example in membrane reactor, both will be happened simultaneously, conversion as well as separation. Even conversion, contacting, mixing, in a static mixer reactor also one example for this integration of the function. Like you know that functions means your conversion function, even separation, this is one function. Even you know that contacting mixing, sometimes you know that you have to mix the fluid in intensive way, what will be the degree of mixing there, that is also required to know. That is actually obtained by that estimation of the you know that that is one important parameter is called Peclet number, based on which if Peclet number is going to infinity, that means here it will be you know that less mixing, whereas it is 0, Peclet number is coming to 0, then it will be called as what is that higher mixing or complete mixing. So, you have to intensify the unit to actually increase this process intensification phenomena based on this integration of the functions there. So, like a static mixer is one of the important unit to mix the fluid intensively. So, that is why static mixer is called intensified unit, or a static mixer reactor is called the intensified unit for you know that simultaneous operation of reaction as well as you know that mixing of the phases. And direct conversion of methane into ethylene with integrated air separation is also one important. In that case, conversion and separation are the functions, and these functions are integrated in a intensification process. And also you will see that here the picture shown in you know slides, that the how this intensified reactor can be developed based on the microchannel based reactor, micro reactor, and also there was some static mixture which is being used for the intensification of the mixing there. Like another important principal feature is called integration of phenomena. In that case, what are those phenomena? Like reaction, phase change phenomena, fluid into solid membrane, even diffusion in membrane. You can say that phase change, solid membrane into product fluid in membrane reactor. These are the features of that is you know integration of the phenomena, you can say. And some other phenomena like that you know reactive, convective, even diffusive heat and mass transfer phenomena, even volume flow transfer in static mixer reactor. So, these phenomena also to be considered for your process intensification. And convective heat transfer phenomena in spinning disk reactor. You know the spinning disk reactor, there the reactor will be rotating at a particular RPM, that is called at a particular rate, so that there will be a fluid mixing inside the reactor, and based on that fluid mixing, that convective heat transfer will be happened. And also you know that in the static mixture, the reaction phenomena, convective and the diffusive heat and mass transfer phenomena will happen there in intensified mixing way. And you will see sometimes you know that membrane reactor or some porous reactor, there will be a phase change of the fluid in the reactor, and also the you can intensify the diffusion of the molecules in the membrane reactor. And you know porous material, through the porous material you can enhance the diffusion of the process. So, that is why these phenomena to be considered integrated way to get the process intensification. Like another important features is called the targeted enhancement of the phenomena, that is here in membrane reactor the reaction, final reaction, what should be that, and also the convective and diffusive heat and mass transfer phenomena in static mixture, and convective heat transfer phenomena in spinning disk reactor, even diffusive mass and energy transport phenomena in micro reactor. So, nowadays this membrane reactor, even static mixture, spinning disk reactor, even micro reactor are coming in market for the process intensification, and different company they are actually using those you know that commercialized product of that is designed based on this process intensification principles, and it is being used nowadays. And also in future aspect, that since the space problem, even number of equipments, energy consumption, based on which you can say that this intensification can be done by integrating these unit operations and also the phenomena of the process equipment. Basic principle of some special technique of process intensification there also, like here different phenomena like centrifugal actions, even microwave reactor, even that some that spinning operation or spinning phenomena, based on which how that the process intensification feature can be obtained or process can be intensified based on those phenomena. Here like centrifugal fields, in this case rotational speed of spinning surface of optimum equipment performance. Here in this case you will see whenever a reactor is spinning at a certain rate, you will see there will be a fluid that will get some centrifugal action, and based on which there will be a generation of that secondary flow phenomena, and based on which that intermolecular attraction will be more, intermolecular that interaction will be more, and there will be that mixing will be more, and also flow phenomena, that is plug flow phenomena will be there, and based on which you can get more intensified way to get the product there, and also there will be some optimum condition based on which you can design the process for your process intensification. Sometimes extremely high gravity field also capable of that producing very thin films there, and if you producing very thin films, there will be mass transfer, more mass transfer, because your interfacial diffusion of the molecules will be enhanced there through the thin film, and in that case mass transfer will be more. So, that is why any chemical engineering processes for the separation, so you have to sometimes produce the thin film for the intensification of the mass transfer. And also another important thing is that for spinning reactor, you will see based on these centrifugal fields, you can produce higher force for mixing of the phases, and also you can increase the contact time of the that fluid mixer in a short path. So, the short path lengths and the high surface area volume can be generated by the centrifugal action, and because of which you can get more mass transfer, because mass transfer is directly related to the that surface area per unit volume, that is called interfacial area. So, interfacial area and also contact time, both are the main important factor for the intensification of the mass transfer, and based on which the separation processes of the chemical engineering operation. And that residence time that I told, that the contact time is that is called sometimes how long these molecules will be residing in a particular reactor. Like if you are using the column reactor, sometimes if you operate some processes by developing soft particles of different gases or liquids, it is sometimes called drop or bubbles. So, in that case if you increase the residence time of the bubbles in a reactor or droplet in a reactor, you can have more time to get the mass transfer there. Like that if suppose consider a bubble column reactor, and in which gas is supplied from the bottom of the reactor, like carbon dioxide gas is absorbed in a liquid. In that case, carbon dioxide gas bubbles will be produced from the bottom of the reactor as a dispersed phase of bubbles. If you produce that more finer bubbles, you can get more residence time there in the reactor, because the residence time depends on the buoyancy force of the bubbles. If you have the more buoyancy force, then immediately those bubbles will go up and it will dissolve at the surface of the reactor. So, if you reduce the size of the bubbles, then your buoyancy force of the bubbles will be less, then it will take more time to come into the top of the column. So, that is why it will stay for long time in the column. Another way to increase the residence time is that if you supply those gas from the that top against its buoyancy, you can get also more residence time there. Nowadays that one important operation, it is called downflow operation. Downflow operation where the gas or liquid droplet, it is supplied from the top of the bubble column, top of the any column or mixing column you can say, and there it flows by the downward movement of the liquid and against its buoyancy, so that the higher flow rate or higher momentum of the liquid, it will actually drag that gas bubbles or liquid droplets against its buoyancy. So, that at a particular operation where the downward movement of the liquid is equal to the buoyancy force, there you can have more residence time. That means, at that equilibrium condition, bubbles or droplets will stay a longer time in the column. That is why the residence time of the column can be actually intensified in this downward operation or downflow column. So, you have to that control those residence time of the gaseous bubble or any substances or fluids there to get more mass transfer. Sometimes for fast reactions it may not be required to get the more residence time there. So, in that case you can operate the upflow reactor or upflow bubble column reactor for fast reactions, whereas in such cases where the slow reactions will be there. So, in that case you have to increase that residence time reaction residence time of the particles or fluid particles by downflow operation. And that sometimes some catalyst particles it will not be actually residing in a column because it is very lighter than water. So, in that case that inverse fluidized bed is also an important intensification of the process where the catalyst particles can be actually controlled by controlling that that movement of the catalyst particles in the downward directions against its buoyancy. So, that is why the inverse fluidized bed is coming. So, this is the centrifugal fields by which you can say that you can increase the intensification of the process, and some examples are given here: distillation process, extraction, boiling, condensation, crystallization, even some example precipitation and gas liquid reactions. These are very important chemical engineering operations. These operations can be intensified, or these intensified operations are being done by the centrifugal fields and based on the phenomena of the centrifugal action of the fluid particles. Another is the ultrasonic fields where you will see that sound is produced through a liquid medium to produce the micro bubbles there. So, generation of the micro bubble is important because to get the more interfacial area for the gas liquid mass transfer operation, there you have to produce more surface area. So, there you can produce the micro bubble for the intensification. And ultrasonic method is one important actually method based on which you can produce this micro bubble. There are several other methods also available like that Venturi, even high pressure gyration systems are also available to produce the micron size bubble. Here ultrasonic field also important, but it is that energy high energy consumed for this generation of the micro bubbles. Also wave generate intense mixing conditions and enhanced the transport rates. In this case whatever ultrasonic waves are generating, there you will see fluid mixing will be higher based on these ultrasonic waves, and in that case the transport rates can be increased based on this ultrasound operation. Also creating a greater surface area for mass transfer, because we can say that here the micro bubble production told that even nowadays nano bubble also is produced for the medical operation there to get the more surface area for gene therapy, even drug delivery operations in the cancer cell. So, in that case you have to increase the surface area even for mass transfer, even reaction for that to get the reactive mass transfer in intensified way, you have to use you have to produce the more surface area. Even extraction, liquid extraction, suppose if you want to extract that propionic acid from the water in some organic solvent. So, you have to produce that more surface area to transfer this propionic acid from the water to the organic phases. So, in that case how to produce that surface area? You have to produce droplet of those organic solvent as well as that water, that is immiscible. Two immiscible liquids are there. You have to produce the droplet of that that organic solvent like paraffin or decanol. If you use decanol to extract that propionic acid from the water, you have to produce the droplet of the decanol or paraffin. So, through which that the mass transfer will be happened there. So, in this way you can use that ultrasonic wave to create more finer droplet there to extract those propionic acid from the water. So, that is why intensification based on this ultrasonic fields for this particular extraction operation. Even processing medium can fracture into reactive intermediates such as free radicals also. Sometimes if you use that micro bubbles, they are even in nano bubbles, you will see in like ozonation process. Nowadays intensification of the wastewater treatment by advanced oxidation, they are like ozonation process. So, like arsenic that removal from the water, how to do that? Generally in the groundwater, generally the arsenic is staying as a that arsenic 3 compound. So, in that case it is very difficult to adsorb those arsenic 3 compound by adsorption process, simple adsorption process. So, you have to convert this arsenic 3 to arsenic 5 by advanced oxidation. In that case ozonation is one of the important advanced oxidation process by which you can convert this arsenic 3 to arsenic 5. Now, for that ozonation process, you will see by formation of ozone bubbles, for that reaction to convert this 3 to 5, you have to produce fine bubbles. That fine bubbles at its interface will produce some radicals, free radicals of that waste radicals. So, that waste radicals will take part into the reaction to convert this arsenic 3 to arsenic 5 easily. After that arsenic 5 you have to adsorb in a resin based any adsorbent or some other, then you can easily separate that arsenic from the water. So, this is one of the way to intensify the process for the separation of arsenic from the water. So, main important thing is that you are producing here free radicals. So, that free radicals can be produced by that ozonation process, and that ozone microbubbles can be produced by this ultrasonic field. So, that particular microbubbles, that ozone radicals will be actually attaching over the surface of the microbubbles, and then this radicals will be acting in a reaction. Another that crystallization process, that is ultrasonic crystallization, that is also one of the important process to get the intensification, the chemical engineering process. Another electric fields like charging up a liquid droplet, sometimes that polarization and the reorientation of the molecular dipoles by electric field, it is sometimes required for the process intensification, like applied to enhance overall rates of reaction in the immiscible liquid systems, whereby a higher degree of stable emulsification is achieved there by these electric fields. Aggregation, coalescence and settling under gravity of electricity charged droplets there. So, based on which you can intensify the process also, like here enzymatic hydrolysis of triglyceride esters to yield free fatty acids and glycerols, where you have to use this stable emulsification based on these electric fields. So, in this way also you can get the intensification, process intensification there. Like electromagnetic fields also another important that process intensification. Nowadays microwaves, everybody using that micro oven for this heating purpose. So, more rapid, even controlled and uniform heating can be done by this microwave, and which will results the higher rate of reaction also for that reaction process. And under microwave, ionic condition came into play for the heating of materials that depends on the chemical species which are involved in that particular reaction. Like several industrial use of microwave heating in the food, rubber and wood industries, they are using this microwave heating for their process. Coupled microwave and ultrasound irradiation capabilities also suited for the continuous reaction in chemical and biochemical processes. So, this process intensification one of the important features that electromagnetic fields by which you can intensify the process. Even that light energy also important there for the photoignition reaction. Even that for the clean process requiring only the reacting molecules in order for the reaction to be activated. So, in that case photoignition actually this is the alternative to the thermal activation of the reactions, and this is particularly relevant for the polymer processing, wherever low temperature generally result in better tacticity control of the polymer, reduced transfer effects which cause of excessively branched molecules, even minimal thermal degradation risks for the polymer formed, even production of caprolactam in the pharmaceutical industry, manufacture of nylon 6, the formation of vitamins D2 and D3. For this process actually these electromagnetic fields, that is light energy, is being used for their process intensification. Even another important features, it is called the well defined structures. You have to develop the reactor in such a way that you have to make a provision inside the reactor, some internal provision to actually obtain more interfacial areas for efficient contact between the reacting system, like packed bed, trickle bed, even some other microstructured packing materials through which the fluid will be flowing and getting the more contact between the fluids and getting more mass transfer. So, enhanced surface configurations can be done by this that packing material, structured packing materials. Even sometimes channel reactors, the micro channels are being actually configured in such a way that to get the gas liquid more mass transfer there. Even heat transfer operations, micro channel based heat transfer or heat exchangers are being developed nowadays. There even some micro bubble column reactors there to get the gas liquid reactions by generating micro bubbles there. So, in that case the configuration of the reactors also important for process intensification. So, enhanced surface configurations, molecular scale structures, example molecular reactors, even meso and macro scale structures such as channel reactors that are important process intensification methods, large interfacial areas for the efficient contact between the reacting streams by generating that that packing materials, structured packing materials there. Examples like hydrogenation reactions, that nitration reactions, even a simple acid base reaction, all of which require rapid mass transfer with the inherently fast that reaction kinetics there. So, for those reactions this structured configured process intensification method is important. Also another phenomena is called the mixing, promotion of the mixing by developing mixing device there. You have to improve the device to actually intensify the mixing of the fluid mixer. So, in that case you can get enhancement of the diffusion, you can get the more turbulent eddies whenever the turbulency of the fluid mixing will be generated by that particular design of the devices. Even additional surface also you can get based on that fluid mixing, which will give you the efficient heat and mass transfer for that particular operation. Even nowadays the intensification of the process are being done based on the development of the that fluid medium or other reacting substances, or that development of the materials, like that ionic liquids, one of the important solvent by which you can intensify the process. Here like that fluorous biphasic systems, there the ionic liquids are being used there, even sometimes supercritical fluids are being used for the process intensification. The use of ionic liquids in various synthetic transformations, like Friedel-Crafts reactions, even Diels-Alder reactions, metal catalyst, enzymatic synthesis, there these ionic liquids are being used nowadays for as a process intensification. A reactant soluble in a non-polar phase can be transferred and reacted in an aqueous phase by use of phase transfer catalyst there. So, their phase transfer catalyst during that phase transfer are being used to intensify the reaction system. And for the Maltesian synthesis, that of 3,3,5 trimethyl cyclohexane supercritical solvent are being actually synthesized to use in the manufacture of resins and varnishes there. So, the supercritical fluids also, by generating or that developing the supercritical fluids, you can also intensify the process. So, we have discussed the different features here in this lecture, different features like that intensification, equipment, based on the equipment, based on the phenomena, based on the that interfacial area, even some other methods that we have discussed. So, I would suggest you to go through these books to know more about this features of the process intensification. So, thank you for this lecture.